Hello everyone, this is Faisal Sabbah and today I'll be talking about the VHDL model for the MIPS pipeline. So the main difference between the MIPS pipeline and let's say the multi-cycle data path is the idea of stages. So in our pipeline we have 5 different stages. We have the fetch stage, we have the decode, we have the execute, we have the memory, and we have the write back. And these stages are separated using registers. So here we have the register between the fetch stage and the decode stage, register between the decode and the execute, register between the execute mem, and of course the register between memory and write back. So let's see why these are defined in our code. So if we search for the IFID register, we see that it's being assigned in this process block. And what this process block basically means is that wait for every rising edge of the clock. If the reset value is set to 1, then set the IFID register to just zeros. Otherwise, set the IFID register to these values, which means that the IFID register only changes when there's a rising edge of the clock. And of course, you can see that the decode values are always continuously being assigned to the IFID register values. So if we go to model sim, we will see that in the traces, so the first signal we have here is our clock, and we'll see that the IFID over here only changes values at the positive edge of the clock. So here we have a positive edge, so the IFID value changes. Over here we have a positive edge, so the same thing happens for the IFID. And this basically sets the different stages for the pipeline. So if we look at, for example, the IDEX register, we see that it has the same process block. It also waits for the rising edge. If reset is set to 1, then set the values of the decode execute register to zeros. Otherwise, set them to these values that are coming from 2 places, either from the decode stage or from the control module. The control module is defined here. And in our diagram, this is the control module over here. Let me use a different color. This is the control module. So this is basically how registers allow us to have different stages or sequential stages in VHDL. In addition, just like our singular multi-cycle models, we have an IRAM which stores our instructions for the program. We have the register array which stores our initial values for our 32 registers, and we have our DRAM which stores our data. So if we change the values of the IRAM, we'll be able to run different programs. However, it's important to note that with the current state of our pipeline, this program will not be able to run properly. So let's see what we should expect this code to produce and what it actually produces on MIPS. So it starts off with load word to register 7 of address 4. So address 4 is of value 1, so we should expect register 7 to have the value of this. Same case here. Let's just change this to an arrow. We should expect that register 8, we have the value of the word at address 8. So this would be it. Register 8 to have the value of this. And then we're adding these two registers to register 9. So register 9 to have the value of, if we add these two together, we should just get 3. And then we store this in 12. at address 12. So address 12 should have the value 33333333, and then we'll branch back to the beginning of the code. So let's see if this is actually how it's implemented, and if the results are what we expect them to be. So if we go to the MIPS, if we go to model sim, and originally look at the register array, we will see that register 7 does have the value 1, register 2 does change to have the value of 2, however register 9 will have the value of 777781. I'll leave it as an exercise to figure out why this program is not working properly the way it should be, and what are the changes that needs to be implemented to be able to support this code. Thank you very much.